Assalamualaikum warahmatullahi wabarakatuh.
We are from Section 14, Kelas A, Ilmu Komunikasi, Universitas Negeri Jakarta.
My name is Indah Sulistiani and my present number is 13.
My name is Fadilaturrahman and my present number is 21.
My name is Sisiliana Rachma, number present 38.
My name is Tasya Firdausi. My present number is 39.
Today we want to tell you about multivariate analysis. This section based on Malhotra book chapter 19 and Der Gibson book chapter 9. We hope you enjoy this video and happy watching.
Chapter 19 talking about factor analysis. First is basic concept. Factor analysis is a general name denoting a class of procedures primarily used for data reduction and summarization. In marketing research, there may be a large number of variables, most of which are correlated and which must be reduced to a manageable level. Factor analysis is used to identify underlying dimension or factors, to identify a new, smaller set of uncorrelated variables to replace the original set, and to identify a smaller set of salient variables from a large set for use in subsequent multivariate analysis. Factor analysis model is somewhat similar to multiple regression analysis, in that each variable is expressed as a linear combination of underlying factors. The key statistics associated with factor analysis are Barrett's test of sparsity, correlation matrix, commonality, agent value, factor loading plot, factor matrix, factor score coefficient matrix, Kaiser-Meyer-Olkin or KMO, percentage of variance, residuals, and script plot. Formulate the problem. Problem formulation includes several tasks. First, the objective of factor analysis should be identified. The variables to be included in the factor analysis should be specific based on past research, theory, and judgment of the researchers. It is important that the variables be appropriately measured on an interval or ratio scale. Construct the correlation matrix. The analytical process is based on a matrix of correlation between the variables. Valuable insight can be gained from an examination of this matrix. For the factor analysis to be appropriate, the variable must be correlated. In practice, this is usually the case. If the correlation between all the variables are small, factor analysis may not be appropriate. We would also expect the variables that are highly correlated with each other would also highly correlated with the same factor or factors. Determine the method of factor analysis. Once it has been determined that factor analysis is suitable for analyzing data, an appropriate method must be selected. The approach used to derive the weights or factor score coefficient differentiates the various methods of factor analysis. The two basic approaches are principal component variance in the data is considered. The diagonal of the correlation matrix consists of unities and full variance is brought into the factor matrix. Determine the number of factors. First is a priori determination. Second, determination based on agent values. Third, determination based on script plot. Fourth, determination based on percentage of variance. Fifth, determination based on split half reliability, and sixth, determination based on significant tests. Rotate factors. An important output from factor analysis is the factor matrix, also called the factor pattern matrix. The factor matrix contains the coefficient used to express the standardized variables in terms of the factors. This coefficient, the factor loadings, represent the correlation between the factors and the variables.
We interpret factors. After getting view of valid factors, we need to interpret the names of the factor. The facility to recognize variables that have a large burden on the same factor is commonly called interpretation. Variables that have a long distance with the axis will be interconnected with these two factors. The factor can be defined as an initial variable. It shall be considered a general factor or an defined factor. Tools that can be used in the factor interpretation is to map these variables using factor loadings as coordinates. The high load on a factor is in the end of shelf and explains the factor. Because it's subjective, the result can be different if done someone by else. At least there are four ways to interpret the factors. First, use the total variance table explained to determine how many factors can be formed. The second, after knowing the maximum number of factors that can be formed, then determine each variable to be grouped by the factor loading method. The third, rotate the matrix component by component matrix table. And the final step is determine the factor by looking at the matrix transformation component table. Calculate factor scores. However, if the purpose of factor analysis is to reduce group of original variables to smaller, combined variables for use in subsequent multivariate analysis, it is very useful to operate the score factor of each respondent. A factor is a simple linear combination of original variables. The score factor will be very useful if future analysis it will be done. Weight or coefficient score factor is usually combined standardized variables obtained from the matrix coefficient score factor. Computer programs allows you to request some factor. Only in a problem of analysis or measure components may the computer accurately calculate the score factor. Even in the component analysis problem, their values are not interconnected. In general factor analysis, a score estimate is obtained, and there are no guarantees for the factors to be disconnected from one each other. After a certain of interpretation, the score can be calculated if we need it. Factor analysis has its own value. In some cases, the choice of several variables should be based theoretically and take measurement into account. As one example of the theory, is strongly recommended that variables have a smaller loading factor are more important than large loading factor. And also, if the variable has a small loading factor but has been measured more precisely. And then select surrogate variables. Apart from the calculation score, the researcher wishes to choose a replacement variable. The surrogate variable or the substitute variable is one variable that can be represent one factor. The greater the opportunity to represent the factor, it is better to surrogate selections of variable must be determined of based on the theory. That is, which variable can theoretically represent factor. The choice of substitution or replacement variable involves the original variable chosen for the next analysis. These sections allows the researcher to carry out further analysis and interpretation of the final conclusion from the original variables. Compared to the score factor, this process works very well if one loading factor for a variable is clearly higher than other loading factor, but it's not easy to make a choice if there are two variables with the same load level. Determine the model fit. The final step is to determine the fit model or suitable model. Viewed from the upper right triangle of correlation matrix reproduction, we can see 5 residues greater than 0.05 showing the suitability and acceptable model. The basic assumption that is principal factor of the analysis is the correlation between observational variables can be concluded or reproduced from the approximate correlation between variables and the factor. The difference between the observations of variables and the correlation produced can be examined to find a suitable model. This difference is called residue. If there are many very large residues, the factor model does not provide a good fit with the data and the model should be. Application for common factor analysis. The matrix value criteria that define two values to be matrix A. Two more factors are extracted. A variant after extraction from a factor is very different from the initial eigenvalue. A value, if not rotated from the matrix vector, will be different, even though the coefficient of the pattern applied is the same. Sometimes, even though the pattern of the loading variables is different from the vector, matrix vector rotation have the same pattern. Sometimes, even though the pattern of loading factors for general factor analysis differs from the main analysis component. With several variable load factor differences, other applications are provided in the context of general variable perception.
Chapter 20 Cluster Analysis Basic Concept Cluster analysis is a class of techniques used to classify objects or cases into relatively homogeneous groups called cluster. Objects in each cluster tend to be similar to each other and dissimilar to objects in the other cluster. Cluster analysis is also called classification analysis or numerical taxonomy. Statistics associated with cluster analysis. Most clustering methods are heuristic, which are based on algorithms. Thus, cluster analysis contrasts sharply with analysis of variance, regression, discriminant analysis, and factor analysis, which are based upon an extensive body of statistical reasoning. Although many clustering methods have important statistical properties, the fundamental simplicity of these methods needs to be recognized. The following statistics and concepts are associated with cluster analysis. First, agglomeration schedule, cluster centroid, cluster centers, cluster membership, dendrogram, distance between cluster centers, a cycle plot, and similarity or distance coefficient matrix. Conducting cluster analysis. The first step is to formulate the clustering problem by defining the variables on which the clustering will be based. Then, an appropriate distance measure must be selected. The distance measure determines how similar or dissimilar the objects being clustered are. Several clustering procedures have been developed, and the researcher should select one that is appropriate for the problem at hand. Deciding on the number of clusters requires judgment on the part of the researcher. The derived cluster should be interpreted in terms of the variables used to cluster them and profile in terms additional salient variables. Finally, the researcher must assess the validity of the clustering process.
Next, assessing reliability and validity. Given the several assessments needed in cluster analysis, no cluster solution must be accepted without an assessment of its reliability and validity. Formal procedures for assessing the reliability and validity of grouping solutions are complex and cannot be fully maintained. Therefore, we lost it here. However, the following procedure provides adequate checks on quality clustering result. 1. Perform clustering analysis on the same data using difference distance measurement. Compare results across size, determine solution stability. 2. Use difference grouping methods and compare the result. 3. Separate the data randomly in two parts. Perform separate grouping for each half. Compare centroid cluster in the two subsamples. 4. Delete variable randomly. Conduct grouping based on the reduced sets of variables. Compare results with those obtained with groupings based on whole sets variables. 5. In non-hierarchical grouping, the solution may depend of the order of case in the dataset. We describe non-hierarchical producer using the data in the table 20.1 and the optimal sharing methods based on the result of a hierarchical grouping. There are three cluster solutions in predetermined. The results are present in the table 20.4. Initial cluster centers are the values three randomly chosen cases. In the sum program, the first three cases are chosen. The classification cluster center is temporary centers that is used from a case assessment. Each case is assigned to the nearest classification cluster center. The classification center is output until the stop criteria are researched. The final cluster center represents a variable means for a case of final cluster. In Windows SPSS, these are rounded up to the nearest integer. Note that AIC is minimal for a three-cluster solution. Comparisons: the center-right cluster in a table 20.5 DOS and a table 20.3 show the cluster 1 table 20.5 correspond a cluster 2 table 20.3 hierarchical cluster. Cluster 2 table 20.5 correspond to cluster 3 table 20.3 and a cluster 3 two-step corresponsible for cluster 1. Interpretation and its implication similar to those discussed earlier. In this case, the three methods, hierarchical, non-hierarchical, and two-step, provide similar results. In the other case, different methods can compress different results. It's a good idea to analyze the data set profile using different methods to check the stability of the grouping solution. Clustering variables. Sometimes, clustering analysis is also used from cluster variables to identify homogeneous groups. In this case, the units used for analysis are variables and distance measurement and calculate for all pairs of variables. For example, the correlation coefficients are either an absolute value or with a sign. Can be used as a measurement of similarity, the opposite of distance between variables. Grouping variables hierarchies can help in identifying unique variables or variables that make unique contributions to the data. Clustering can also be used to reduce the number of variables. Related to each cluster are linear combination of variables in a cluster, which are called cluster components. A large set form of variable can often be replaced with a cluster component set with little information loss. However, the number of cluster components give does not generality explains as so much variance as number to same main component. Then, why should variable group be used? Cluster components are usually easier to interpret and main component even if the letters rotate. We illustrate the grouping of variables with examples from advertising research.
Chapter 9 Time Series Analysis. Time series components. First, secular trend. Secular trends are defined as general movements in the long run. This movement can be either a straight line or parabolic that goes up or down. The method that is widely used to determine trends in the method of moving average and least squares. 2. Cyclical movement. Cycles vector are data patterns in time series that occur and recur over several years. This iteration can occur after 5, 10, or 20 years or more. For example, of movement cycles are business cycles and economic cycles. Entry is seasonal fluctuation. This season vector is shown by regular annual patterns. Seasonal variation repeat every year. Example of season vector are sale, trade, demand, production, inventory, recruitments, and others. Usually at certain times of the same year, an increase occurs and will decrease again at other times. This will be repeat the following year. And the last is irregular variation. This variation in an unpredictable up and down movement that occurs randomly. Smoothing method. Smoothing methods are widely used to eliminate or reduce randomness of time series data. The method commonly used for smoothing purpose data is a moving average method of measurement response within a certain time period or exponential smoothing method. Moving average. By using this moving average method, the periodic series of the original data is converted to a smoother moving average series that is less dependent on oscillation. This is a formula of moving average. M is an odd number. Y is the process response at time t. Yt mean 1 is the process response at time t mean 1, and so on. For example, if the moving average is calculated on the basis of an interval of 3 periods, then
9.2.2 Exponential starting. Another smoothing method that is often used the exponential smoothing. This smoothing method is sometimes more efficient than moving average because its ability to calculate a smoothing value for each response measurement. The exponential smoothing response value employed is often expressed as you can see formula in PowerPoint.
Trend method and relationship analysis. In addition to using the smoothing method, future projections of the value of variable associated with certain time series data can also be estimated using the trend method and relationship analysis.
9.2.3 Use of starting methods for future projection. For the oscillation of a value at a particular time, the use of the moving average method requires the average value k from the previous time data to the project data value at the specified time. The general formula for the moving average method for the purpose of project of value at a time t is, you can see the formula on the PowerPoint.
If the calculation is based on historical data from one variable, then it can use 5 methods. First, free trend method. This method is commonly used to analyze preliminary analysis, which provides an initial overview of a problem at hand. Second, semi-average trend method. This method can be used by forming an equation like a Bayesian analysis, but this method can only be used if the data is even, so that it can be divided into two equal groups. Third, the trend moment method. This method is an analytical method that can be used to form equation to equals a plus bx as presented in the semi-average trend method. But this method doesn't have the requirement that the amount of data must be even. Fourth, less square method or small amount square method. In this method, the model used can be linear or curvilinear. If the model is in the form of curvilinear transformation, it needs to be transformed first. And fifth is quadratic trend method.
The definition of decomposition method are the solving of some pattern to be a pattern section that show you each component periodic series separately. Each component was identified separately. The projection from each of them can combine for produce the future prediction based on periodic data. Decomposition method useful for us to increase the accuracy of data and to enhance the comprehension of data array behavior more better. And also more easier for management to do short-term planning or long-term planning, because without planning, the successful of management will not come through. Seasonal are the variation of the movement that takes a place periodically in period of 1 year. The amount of the seasonal variations is called the seasonal index. Second of the composition method are trend. Trend is a up and down movement to show you a condition for a long time. Trend is low, long, and one-way movement. Time series data shows that there is a tendency to change the movement of condition for a long time. This pattern is called a trend, or it can also be called a pattern that underlines data the last 4 years. Third are cycles. Cycles are trends that increase or decrease over relatively long period of time than seasonal variation. Cycle patterns occur in more than 1 year, so cycle patterns cannot be included in short-term forecasts. This pattern is only for medium-term forecasts or the long-term forecasts. And then the less irregular or error. Random variations or error can due to unexpected factor such as bankrupt, natural disaster, certain promotions, and other events that have irregular patterns. This random variations is needed to determine the security inventory, and anticipated supply shortage can cause in a surge in demand. Symptoms of seasonal variations are a tendency for increased demand for goods followed by price increases at certain period, which will recur periodically each year. Classical model decomposition. You can see the formula at the PowerPoint. And we define YT, regular series value for the period. TT, trend component for the period. ST, seasonal component for the period. CD, cyclic component for the period. And IT, irregular component for the period or error component for the period. In this slide, I will to explain you about step by step. The formula you can see at the PowerPoint. I just explain the step by step with the word. First, calculate moving average that have a period length. The second, calculate moving center average to separate random component. The third, divide actual data or YT with moving center average and multiply 100. And then calculate average ST or IT at individual seasonal for dispel the IT component. Next, do the correction factor for get the index seasonal absolute. And then determine the trend that match with data. Then determine cyclic components by dividing data. And the last, determine the forecasting with YT, TT, XIT, XST, and IT.